So today's lesson is the first of the area unit, and we're going to be looking to find area of quadrilaterals and triangles. So we're going to begin with rectangles and squares, and then move on to triangles, parallelograms, rhombus, trapezoids, and circles. So it's going to be a big area unit. We're going to now be using the geometry textbook. So make sure that you know where your textbook is if you're at home. If you do not have your textbook with you, don't worry, I'm going to post the pages to Schoology, so you'll get to see those. And just in case folks don't have their textbook, because I'm also posting the solutions. So I'm going to be giving some even numbered problems and odd numbered problems. And since the back of the textbook only has the odd numbered solutions, I'm going to post the teacher's edition pages to Schoology so you can see the answers to all of the questions. Okay, so perimeter. What is perimeter? Perimeter is the space around a shape. So if we think about a fence, right, fencing, we add up all the sides. So for any shape, we're going to add up all the sides. For a rectangle, if we think about a rectangle, we can have length and width. Oops, length and width. Or we can have base and height. Okay, so length and width is the same thing as if you saw base and height. So just make sure that you're looking at those interchangeably. That's okay. And so if we have the formula for a rectangle, I think we went over this earlier in the year, where we have twice the width plus twice the length, that's the perimeter. And then for square, we know all the sides are congruent, so we have 4 times the side length, which we call S. Okay, so if we have a square, sides are S. Okay, so the units for perimeter are just going to be units. They're going to be centimeters, they're going to be yards, they're going to be inches. So we have to make sure that we're using the appropriate units. Okay, so in looking at the perimeter of a rectangle is 52 feet. The length is 2 feet more than 5 times the width. So the first thing that we're always going to do is draw a picture. That's the first thing. So if we know that the length is 2 feet more than 5 times the width, if our width is here, 2 feet more than 5 times the width, we have 5w plus 2. So we know that the opposite sides are congruent in a rectangle as well. So drawing a picture is equivalent to a let statement, but now we have to use our formula. So if the perimeter is 52 feet, twice the length, plus twice the width, and we can solve. So 48 equals 12w, sorry, and w is 4. So if our width is 4, that means 5 times 4 plus 2 is 22. So the dimensions of the rectangle are 4 by 22 feet. Okay. And so when we looked, I believe we looked at problems like this earlier in the year, but you're always needing to draw a picture, mark down what you know, create an equation, solve, and then answer the question. Okay, so area. Area is the space measured inside of a shape. So if we're thinking about how much paint do we need, how much wallpaper we need, how much carpet should we order for the floor, okay, that can all be considered area, so this space here. So we want to think about how much space can go inside of that rectangle. So for a rectangle, we have some new formulas now, base times height, and for a square, we have side squared. So if I'm drawing a rectangle, we have our base and our height, or the length and the width. Okay. Notice how the height and the base are perpendicular. And then for a square as well, the base our sides, side times side is side squared. That gives us these are also at a right angle. So the base and the height must be perpendicular. This is going to be very important when we start looking at all different formulas for area of figures, area of quadrilaterals in particular, and we need to make sure we know that perpendicular, the base and the height must be perpendicular. Okay, so the length of a rectangle is 3 more than the width. So the length of a rectangle is 3 more than the width. So here's my rectangle, and the length is 3 more than the width. So from here, we know that the area is 40 square inches. So notice how the units are square inches. They'll be inches squared or units squared. Okay, so the area is our base times height. And we know the area is 40. And we know that our base in this problem is 3 plus w, and we know that the height is w. So when we're plugging everything into this formula, we know 40 equals w times 3 plus w. And this looks like a problem that we began working on last few classes with the zero product property. So from here, when we distribute, we have 3w plus w squared equals 40. And we need to rearrange into standard form. So we have 0 equals w squared plus 3w minus 40. So I just rearranged so it's in standard form. So in looking at this, we have to think what are factors of negative 40 that add up to 3. And I found they were 8 and then minus 5. So then when we're going through it, we get w equals negative 8 and w equals 5. But let's think about this. Can a length have a negative width? Can a rectangle have a negative width? No, it cannot. So we may have to reject one of the answers we get and accept only one of the answers. So 5 equals the width, and 8 equals the length. Or we can say this is our height and this is our base. So either one, I'm okay with you interchanging base and height and length and width. But we just have to know that they are perpendicular to each other. Okay, so let's look at a problem with a square. So if we have the area of a square is 24, we want to know the length of one side. So area equals side squared. So here, if our area is 24 and we have side squared, how can we solve for s? To undo this thing being squared, we have to take the square root. So s equals the square root of 24, which is 2 root 6. So this brings back some radical material. And now if we wanted to find the length of the diagonal, we know we have 2 root 6 and then 2 root 6. Do we remember a 45, 45, 90 right triangle? So special right triangles will come back in this unit. And to find the diagonal, we take a side and we multiply it by root 2. So we have 2 root 12, which we then can simplify into 2 times 2 root 3, which is 4 root 3. So the length of the diagonal is 4 root 3. We can say units. Okay, so special right triangles will come back within this unit. Okay, and then looking at these problems, how would we find the area of these figures? Notice here we have 4 and 4, and then 4 and 4. So I recognize 2 squares. We have 4 here and 4 here, then this square has an area of 16, and this box has an area of 16. So this is 32, square units. Or we can say 32 units squared. You can write it that way as well. And then for this next figure, we have to think about how we can create two shapes that we know. So I see a rectangle right here. And I know that the opposite side here is 6. So if this length is 6 and the whole thing is 9, then this here has to be 3. So I have 4 times 3 here, which is 12. So think about what this length would be. We have 10 right here. And then this length here, we don't know, but look, opposite it, we have 4. So this is 14. So we have 6 times 14. We have 84. So when we add them together, we have 96 square inches. So make sure that when you're going through these problems, we're reminding ourselves how to use the zero product property, create let statements, and remembering and recalling our special right triangle properties.